In any competition, whether it's a game of chess, a football match, or a global conflict, the winner is usually the person who can do one specific thing the fastest. Military strategists call it the OODA loop: observe, orient, decide, and act. If you can see what is happening, understand it, make a decision, and act on it faster than the other person, you win. Period. For thousands of years, the speed of that loop was limited by the human brain. How fast could a scout run back to a general? How fast could a human read a map? But today, militaries around the world are doing something way faster than a human can imagine. They are taking the human limits completely out of the equation. Armies across the globe are currently undertaking the largest technological pivot since the innovation of the internet. They are integrating artificial intelligence into absolutely everything. From how they watch the globe, to how they supply their troops, to how they organize the battlefield. There are a lot of scary movies about AI in the military, but today, I don't want to talk about science fiction. I want to show you exactly how this technology is actually being used right now. We are going to look at the real research, the actual companies involved like Palantir, Anduril, Shield AI, and Lockheed Martin, and the deep science of modern defense. And by the end of this, I want to show you exactly what it means to hand the math of war to machines. Let's get into it. Imagine you're an intelligence analyst. Your job is to stare at satellite images and find 3 specific enemy supply trucks. You have exactly 10 minutes before the satellite moves. Go! Modern militaries have a problem. It's called data deluge. They have thousands of drones, satellites, and sensors collecting petabytes of video every single hour. But a camera is just a piece of glass. It doesn't know what it is looking at. This is why defense organizations around the world started investing heavily in computer vision AI, teaching computers how to see. To an old computer, photo of a school bus and a missile launcher are just a bunch of pixels. But researchers trained AI algorithms on millions of images, teaching the neural network the specific geometric patterns of military hardware. Now, instead of humans staring at screen for hours, the AI watches the drone feed in real time. A recent study on geospatial intelligence showed that these AI algorithms can process satellite imagery up to 80 times faster than a human team. It highlights the trucks, alerts the commander, and filters out the noise. The AI isn't making a decision to strike, it is just acting as the ultimate pair of glasses, pulling the needles out of this haystack instantly. But there's something critical that doesn't get talked about enough. AI is only as good as the data it learns from. If the training data is flawed, biased, or incomplete, the AI doesn't know that. It just executes. A misidentified building, a misread pattern, a corrupted data set, and the system confidently points to the wrong target. At machine speed, with machine confidence, the consequences can be catastrophic. This is one of the most serious and underreported risks of deploying AI in conflict zones. So, the AI can see, but seeing isn't enough. You have to understand, and this is where a company called Palantir comes in. For a long time, militaries had a silo problem. Different branches had their own data. If a commander wanted to know the big picture, they had to manually call different departments, read different spreadsheets, and try to mix them together in their head. Palantir builds the bowl to put all these pieces into. They created an artificial intelligence platform, or AIP, that manages large-scale data modeling and theater-level command. It takes data feed from different branches and fuses them into one massive, living, breathing digital map. Instead of staring at Excel or spreadsheet, a military commander can open a chat window and literally type, "Show me all hostiles movement near this border in the last 24 hours. And tell me which of our supply bases has enough fuel to deploy a rescue helicopter." Palantir's AI translates it, searches the data, and gives a perfect logical answer in seconds. But there's another type of data in defense: text. Endless, massive amount of text. Intelligence reports, intercepted radio transcripts, foreign news articles, diplomatic cables. If a team of human analysts needs to find a hidden pattern in 10,000 pages of text, it takes weeks. So defense organizations started working with frontier AI companies, using large language models with massive context windows, feeding them the equivalent of several thick books of text at once, asking them to find unusual patterns across thousands of intelligence reports. But this has sparked an enormous debate as well. How much access should commercial AI companies have to classify military systems? And what restrictions, if any, should they be allowed to keep? Different companies have drawn very different lines. Some have refused certain military applications outright, others have leaned in. The politics of which tech organization will or will not work with defense organizations is fascinating. Massive debate on its own. So we have the analyst and the theater level command, but how do you connect all the hardware on the actual battlefield? This is where the company called Anduril Industries comes in. Their job is to consolidate separate systems into one unified, mission-ready ecosystem. At the center of this is Anduril's software called Lattice. Lattice is an open architecture AI operating system. It takes all the real-time tactical data from different sensors, drones, and legacy systems and ingests it into a common operation picture. While Palantir handles the massive theater-level data in the cloud, Anduril's Lattice handles the real-time data right on the tactical edge. It can connect sensors and autonomous systems to create an extensible network on the battlefield. And speaking of autonomous systems, the hardware itself is getting incredibly smart. Modern military strategy is shifting away from a small number of incredibly expensive machines towards thousands of small, smart, autonomous drones. If a swarm of drones loses its GPS signals or gets its communication jammed, they don't just fall out of the sky. Hivemind allows the unmanned system to sense their environment and generate new navigation alternatives based on the targets and conditions without constant remote control. But AI isn't just about flying small drones, it is learning to fly actual jets as well, fighter jets. Lockheed Martin's Skunk Works division developed a test aircraft called the X-62A VISTA, a flying laboratory designed specifically to test AI and autonomy in real airspace. AI agents autonomously flew the X-62A, executing advanced fighter maneuvers. During testing, engineers realized something fascinating. AI's biggest advantage wasn't aggression, it was pure speed. The AI was evaluating options and adapting its maneuvers faster than a human pilot could physically react. The aircraft remained within real-world safety limits while continuously optimizing its own performance. And that brings us to something that defense analysts are increasingly worried about: flash wars. You have probably heard of flash crash, when automated trading algorithms on stock markets react to each other so fast that billions of dollars evaporate in minutes, with no single human deciding whatsoever. The whole thing happens and resolves before anyone even understands what occurred. Now imagine the same dynamic but with weapons. A flash war is what happens when AI-driven military systems on opposing sides begin reacting to each other at machine speed, faster than any human commander can follow, let alone intervene. One system detects a threat and escalates. The opposing system reads the escalation as a threat and responds. Within seconds or minutes, you have a conflict spiraling out of control, driven entirely by algorithms reacting to algorithms. Nobody decided to start a war. The machines just outpaced the humans who were supposed to be in charge. This isn't science fiction. As more nations integrate autonomous systems, sensors, and AI decision support tools in their own defense architecture, the risk of this kind of automated escalation grows. The speed that makes AI so powerful in military context is the exact same feature that makes it so dangerous. This brings us to the most important question of this video. If AI systems can connect the battlefield, fly drone swarms, and pilot fighter jets, who pulls the trigger? The idea of autonomous weapons is scary. It sounds like the Terminator. But here's where military AI policy currently stands, at least on paper. Several major defense organizations have adopted formal policies mandating what is called human in the loop. The principle is simple. No matter how smart the map, no matter how fast the analysis, no matter how well the AI flies the jet, the AI is not permitted to make the decision to use lethal forces. The AI is a tool. It gathers the puzzle pieces, but a human commander must look at the puzzle, take moral responsibility, and make the human choice. Whether those rules are actually followed and whether they can survive the pressure of real conflict is a completely different question. When you look deeply at how this technology is actually being used today, yes, AI is being built for combat scenarios, but a massive portion of military AI right now is focused on logistics and awareness, routing food, fuel, and medical supplies, or mapping disaster zones for relief operations. The stated goal from many defense strategies isn't necessarily to fight faster, but to achieve deterrence. The theory is that if AI can perfectly monitor borders and give commanders total clarity, removing the fog of war, it makes attacking mathematically unappealing, because surprise becomes nearly impossible. But whether this AI actually prevents conflict or simply escalates the speed of war beyond human control, potentially into flash forward territory, is still an open and urgent question. The AI isn't replacing human judgment yet, but the speed at which these systems operate is incredibly beginning to compress the time humans have to exercise that judgment. And the ultimate choice of how far we let these systems go still rests entirely on our shoulders. This is Sunmin speaking from Jamilius. Thank you for watching.